It appears to be the top of the hour, so welcome everyone to the September 19th edition of the Vancouver Power BI and Modern Excel User Group Meetup. Excited to have both Joseph and Melissa here to help us out today to talk about Power Query and Power BI and all good things around that. So, of course, as by standard, we will start with a big thanks to the sponsors that make this possible. If you're not familiar with SkillWave, this is the training company that I run with Matt Allington, where we teach you how to be awesome in Excel and Power BI. SkillWave is a division of Excel Guru Consulting Inc., which also happens to be the company that distributes and builds Monkey Tools, an Excel add-in to help you build better data models faster, among other time-saving things in Excel. Our next meetups that we have coming up, our next Power BI track a month from now, we're going to be having Ann Walsh come. This again will be an early start. We're going to be at 9 a.m. Pacific time. That's because Ann is going to be joining us from the UK, and we're going to be talking about star schemas and that, so that'll be cool. And then in a couple of weeks, I'd like to flip the order on this one a little bit. Let's talk about Excel. I'm actually going to talk about Monkey Tools because it's been a while since I've done a presentation on this. So this will be in our normal 5 p.m. Pacific time slot on October 10th. And I'm going to look at just some of the cool things that Monkey Tools does, both from the free and the pro version. So if you haven't learned about Monkey Tools at all, definitely come and check it out and see what this tool can bring to you. It's pretty awesome, does some amazing things. Speaking of Monkey Tools, if you want to learn earlier, we do have a free course on how to do that. I'll plug that when we're into the course as well. But this will teach you about all the different features that are actually going through that particular software. And we should also talk just quickly about what's new in it. I haven't done a ton of things that are really sort of, front-end facing lately, but on September 13th, I did release an update which actually allows bug fixes. As always, man, my animation game is just not on today. Let's go to the top of the list where we talk about better license management. That's what I was really hoping to see first. And also, if you are working in the BiblioMonkey and you have your cursor sitting in the middle of your DAX measure and thinking, man, I wish I could indent this, you can now press Control-I to indent your DAX measure inside BiblioMonkey. So just helps a little bit there. And again, of course, the free course, I'll just throw out a mention of there. So hopefully by next meetup, I've actually figured out how animations work in PowerPoint again, because once upon a time in my life, I did know how that happened. If you are interested in taking the Excel Fundamentals Academy, this is a fantastic program where we actually review, basic formulas in Excel, data visualization, teach people about Power Query. I actually spent the last 3 days in person with a company actually teaching this particular program, but this version here is all online with all the videos, access to my Ask Ken sessions that we do twice a month, all kinds of good stuff there. This is a great program for people who want to fill in knowledge gaps around Excel, really start using Power Query and building some good business intelligence solutions with regular old pivot tables and data visualizations and charts. Maybe it's not you, maybe it's someone in your organization, but definitely, throw a recommendation to it. It's a great program. If you already know how to use pivot tables and you want to take your Excel and Power BI reporting game to the next layer, you might want to check out our Self-Service Business Intelligence Academy. This is my biggest training program. It's got, actually, this isn't up to date. It's 57 hours long now of material. There's a ton of stuff that's in here, including the Ask Ken Anything sessions. You get a copy of my book. You get a copy of Monkey Tools. You get all kinds of good stuff. And you get to learn all about how to use Power Query, Power Pivot, dimensional modeling, DAX measures, and Power BI to build some amazing things all the way through like row level security and setting up multi-user solutions. So it's a very, very comprehensive program. It's really good. So if you're interested, you should definitely check that out. This meetup, as all meetups, is recorded and will be posted on the SkillWave YouTube channel within 24 to 48 hours of the meetup completing. Just give me a little bit of time to process it and whatnot. Once it is ready to go, I will post in the meetup group a notification there. So if you did RSVP for the meetup, you'll get notified about that when it is live. Last thing I'm going to say before I hand the stage over to Joseph here is if you'd like to come and speak here at our user group, we would love to have you. We're always looking for new people and new ideas and cool things that you've actually done. Anything involving Excel, Power BI, or the Power Platform, we love to hear about. Just fill out this little link survey here. You'll also find that this slide deck is already posted on the Meetup group, so you can download it to get the live links right there. And that's it for me. I'm going to turn the stage over to Joseph now, who's going to give us the what's new in Power BI for September. At least, Emma, are you?
Or I'm going to be doing something else, but yes, I will
Oh,
be
okay, fair
sharing
enough.
something.
Joseph's going to give us a presentation, so there we go.
A quick
Fantastic.
thing. Thanks, Ken.
Awesome. You bet.
And yeah, welcome everyone to the September meetup group for usually what's new in Power BI. This month, as we can see from the Microsoft blog, we have August, which I obviously reviewed last month, and I got very excited when earlier today I saw September 2024 in the headline of a blog post, but unfortunately it was just for the data gateway. So there's no new September blog post of the feature summary for what's new in Power BI yet. I haven't seen a September download. I checked earlier this morning. It was still August, so that might have updated in the last couple hours. However, I think in the App Store, the September release may be out. I don't know for sure, just sort of murmurs I've been hearing. So instead of doing what's new in Power BI, I am going to just do a quick demo of a DAX example of using the DAX query view in Power BI, just because I've demoed it so many times over the last couple of months of what's new in Power BI. New functionality is coming out every month, and I figured just going through a short demo of some of the things I haven't really showed yet for what's new in Power BI. But it looks like for next month I'll get to do September and October together earlier in the morning. So in Power BI, we have a fourth view now, DAX query view. This has been out for, I think I've said a couple months for the last couple of months, so maybe half a year, even close to a year now, where we can write our DAX queries in a dedicated, more of a dedicated development environment. So to actually define measures in our data model, we can use the define function, the define word, and I'm defining a measure on my fact table called loans balance, and then I see the DAX formula to the right-hand side. So I've demoed some things like this of how we can build measures and how we can do stuff like that. But one thing I haven't really looked at is this command palette up here. So it is a button on the ribbon on the Home tab in the DAX query view. I can hit command palette to bring that up. And we see we have a list of all this sort of functionality available to us in the DAX query view as we're developing our DAX measures for our data model. We can also bring up the command palette with the keyboard shortcut Control-Alt-P. And if you use like Visual Studio or Azure Data Studio, this is a really familiar experience to what we see in some of those tools as well. But some of the shortcuts that definitely don't know everything of all the shortcuts in DAX. I'm still getting used to it. But some of the ones that I've liked and found really useful is like copying lines. So typically what I would do if I was defining a few different measures is I would just like with my cursor grab, copy, sort of click, paste down here. If I wanted to create a new measure that's like essentially the same, I just have to update some information, like if I wanted to call it credit card balance and set the account product instead of loans to be credit card. So you can still totally do that. That still works. That's all good. But we do have some nice keyboard shortcuts that can help speed that up. If I hit Shift-Alt down, that copies my current line down underneath the line that I'm currently hovered in. So if I do that a few times, I can quickly copy lines of code and go in and just update to like deposit balance or insurance or investments or whatever. And I'm quickly creating 4 measures, whereas previously this would have taken a lot longer. Let's just finish that off. So now I have 4 measures developed pretty quickly in the DAX query view. If I hit update model with changes, that applies all 4, creates them in my model, and I can now see them in my fact table on the right-hand side in this tables pane over here. Another shortcut that I like, which again, there's buttons on the ribbon for this functionality, but I like doing it with the shortcut now too, is if I just highlight like fact account product, In this part of my measure, I'm referencing the account product in my fact table, which is actually the foreign key of the relationship between my fact table and my product dimension. And maybe I want to update this to point to the account product column in my product dimension instead. So a few different ways that I can sort of get to this functionality to quickly update it. I can just highlight it like this, right click, change all occurrences, and we can see now we've selected all instances where I'm referencing that column in my fact table. And I can instead go to my product table and reference account product from there and close that out. And now I've quickly updated all 4 of my measures. I can update my model with all 4 of these changes. And just, well, with 3 of them, I don't know what happened there, a little bit of a glitch. Okay. And with all 4 of them, I can quickly do that as well. The keyboard shortcut for that is Control F2. So if I selected like my total balance measure, for example, Control F2 goes to all of those. And if I wanted to change this from total balance to mean balance, as an example, we can do that, update. And now my measures in my data model are all calculating, or all of these measures are using the mean balance measure in the calculate statement, as opposed to total balance. So the DAX query view has made it really easy to like quickly develop our DAX measures, whereas previously we'd have to rely on either an external tool or just do it in a little bit of a slower way, a little bit more clicky, draggy, droppy way. And now we have some of these additional keyboard shortcuts available to us as well. It can really help speed up that development process. My favorite thing that I like about DAX Query View, and I have demoed this before, but I just want to highlight it again, is I really like the Format Query button. And not only does it format the query that we see right now in our DAX Query View, but it actually updates all of what our measures look like as well. So if I just go into a different view just for a second and go to my fact table, and I go to credit card balance, if I zoom in, we can see that all of this measure is, this DAX formula is all on one line, and it looks exactly the same as what was in my DAX Query View. Now that I've formatted this, if I update my model with these formatted measures, and I go back, we can see that that formatting now goes through to other areas of the report as well. So if you're just sort of doing a little bit of rough development of your DAX measures and you're not making it look pretty, you can now have a really quick, easy way, format your query, and it pushes it to all areas of your data model. So when you're dropping them into measures, or you maybe just need to remember what this measure is, how is it defined, we can see it with sort of the nice indentation, different line breaks as well. So that was just a quick 5-10 minute demo of DAX Query View. As I say, there's nothing new in September of Power BI yet. Last month it came out on the 21st, I think. It's only the 19th. But next month, hopefully, if the timing works out, I'll have 2 months of what's new in Power BI to present. So with that, that's all I have for today. Just a quick little demo. I'm happy to pass it back to Ken and get ready for the feature presentation in Power Query, which I'm really excited about. So awesome. Thank you, everyone. And yeah, back to you, Ken.
Thanks, Joseph. Appreciate it as always. And yeah, now it's my great pleasure to welcome Melissa de Korte back to our stage here again. Melissa's been here, oh man, what is it, like 9 months to a year ago? Does that sound about right? I don't know.
A year ago, yeah.
Yeah, time flies. I can never keep track of what happened in the past. It's crazy. But just for everyone's knowledge here, as far as Melissa's presentation goes, we discussed it beforehand, and she said pay for questions. She is going to pause to take questions, but if you want to fire them into the chat so that we can feed them directly to her when that happens, that would be perfect. And Melissa, the floor is yours. What would you like to tell us about Power Query today?
That's the thing, right? Isn't it? Well, that's something that we'll soon find out. So let me see if I can share my screen, and please let me know if you can see that.
I can see it. Looks fantastic.
Awesome. All right, time to kick off. That should not be there. Let's move that to the side. All right. So hello, everyone. Today, we are going to dig into ways to transform values, specifically structured values in Power Query. Now, from my experience, the ability to transform structures unlocks endless possibilities, and that's why I'm very excited to share some of these techniques and these methods here with you today. So this session is not just about finding a solution, but also about discovering how to apply that in different ways. I've spent plenty of time redesigning queries that I found on forums, and here's what I've noticed. As users, we tend to stick to what we're most familiar with. Of course, there's nothing wrong with that, obviously, but I do want to expand that horizon a bit. So today, we're not just going to answer the what, so find a solution, but we're also going to explore the how, using different methods to incorporate a solution into your query. So by the end, you'll have more options and greater flexibility when designing your queries. To that end, I've prepared 2 examples that focus on the 2 most common challenges I know many users struggle with when dealing with nested structures. That's navigation and that's scope. So here's what you can expect. First, I'll introduce structured values, a bit of theory to get us warmed up, and then we'll jump into the first scenario, navigating a structure. We'll explore different methods to incorporate that solution into our query before moving to the second scenario that deals around handling scope, for which I'll also provide an alternative approach. And of course, somewhere along the way, we'll also cover some key concepts as we go. I think this is a good time to introduce myself. Here we go. So my name is Melissa, and I focus on digitization, automation, and data analysis. I'm an enterprise DNA expert, Fabric community super user, as well as MVP, and you may have come across my post on LinkedIn, where I share tips and tricks using the hashtag #PQTodaysMenu. Feel free to connect with me in that space. One of my proudest achievements is, of course, the publication of the Definite Guide to Power Query M, a book that was released earlier this year, and that focuses on the M language, enabling you to get more stuff done with Power Query. Now, should you have any questions on what I'm presenting, you can use the chat. Please prefix your question with a Q. That always makes it easier to find. I will pause, as Ken already mentioned, at certain points during the presentation so we can address any questions that may have come up. All right, let's get down to business. And the first thing that I want to establish is an understanding of what structured values are. So in the M language, structured values are the building blocks that store and organize our data. There are 3 types: lists, records, and tables. And I'll quickly introduce each one. So lists are by far the most basic structure, I would say, and you can think of a list as an ordered sequence or a collection of values. And here is how you define a list in M. A list is initialized using those curly brackets. Those are the list initializers, right? And between those curly brackets, you can enter comma delimited values. However, instead of commas, I've used the dot operator in this example to generate an incremental sequence of numbers, in this case running from 1 all the way up to 5. Now you can access items in a list by referring to its zero-based position, again, inside a set of those curly brackets. Now, that process is called item access. So for instance, referring to 1 inside a set of those curly brackets, that will get us the second item from this list, returning the value 2, because you need to remember to start counting from 0 when it comes to positions in the M language. So next up, the record. And a record is more like a dictionary. It consists out of fields, where a record is a name and a value pair. right? A record is initialized with a set of square brackets, and between those square brackets, you can define your name value pairs separated by commas. So here on the screen, you'll see that I've created a record that consists out of two fields. The first one is named 1 with a numerical value of 1 assigned to it, and the second is named 2 with the numerical value 2. And of course, you can access items in a record as well. You do that by referring to the name of the field you want to access within a set of square brackets. Now, that process is called lookup or field access. For example, here we're referring to the field name 2, and that will yield its numerical value. And finally, there are tables. Now, tables are the primary structure in Power Query. Think of a table as a collection of rows or a collection of columns. And typically a table will be the result of connecting to a data source, like a file or a database, for example. However, you can also create them inside the Power Query editor through the Enter Data window or by writing a bit of M code. Now that can come in handy when you need to create small supporting tables for your model, or even more complex dimension tables, such as a date table. In this example, the hash or found table expression is used to initialize a table. And that table has 1 row and 2 columns. It consists out of an empty list and an empty record. So here's a quick recap. There are 3 structures in the M language: lists, records, and tables. Curly brackets are used to initialize and access a list, whereas square brackets are used to initialize and access a record. But the primary structure in Power Query is a table. And when you access a single row within a table, that will return a record, and accessing a single column will return a list. So before we head over to the Power Query editor, are there any questions on these structures?
I don't see anything in the chat as yet, Melissa.
Perfect. All right. So let's head over to the Power Query editor. It looks like I've already zoomed in. Let's try that again, make that a little bit bigger. All right. So when working inside the Power Query editor, it's best practice to have both the formula bar and the query settings pane visible at all times. So when that's not the case, you can head over to the View tab and you can toggle them on right here. All right. So let's take a look at our first scenario, right? That will focus on accessing values within a structure. So here's our query, right? And I think accessing values is a fundamental skill, and it's also one that generates a ton of forum questions. I can tell you that. So whether you're working with a simple or a more complex structure, the great thing is that the techniques used to navigate a structure, that never changes, that stays the same. So the elements you use to navigate your structure, or the order in which you apply, that may change, but the key takeaway is this. By applying the theory that we just covered, you will be able to handle anything that comes your way. So just imagine that you've connected to a data source and you received a table looking like this. It has just 2 columns, and the second column that contains a nested structure. In this case, it's a record. Now, the task you were giving was very simple. Report the current phase of each of these projects. So those details must be hidden away somewhere within that record. It's time to do some exploring, all right? Now, to get a glimpse inside a nested structure, you can click on the white space beside it, and a secondary preview will open at the bottom of your screen. So here we can see that all of these records contain a single field, and that field has a list value assigned to it. Now, when I click on the white space beside that list item at the bottom of my screen, nothing happens. But that's okay. We can explore further while we're building our solution. So to get that started, I'll use the go-to method for transforming values, and that's a custom column. So the custom column, you can find that on the Add Column tab. It's right here. It's this beautiful button. But I usually use the mini table icon in the top left corner of my table. You'll find Add a Custom Column there as well. So just click that, and this dialog box appears. Now, in this dialog box, you can specify a new column name as well as a formula. So here we go. What I want to transform is the value that's currently within the phases column, right? So from the available column section on the right-hand side, I can double-click that name to bring it into the formula editor, right? And we saw that when we looked at the preview of this record, that it had a single field and its name was phase. So we can apply lookup or field access to obtain the value that's stored away in that field. So add a square bracket there, and it will suggest the columns that are available on this side. Now, phases is pretty close to the name that I want to enter, so I'll use that, and I'll remove the S. Now I'll hit OK, and there's our list. So again, when I click on the white space of that record, I see that list here. We can't look inside that, but I've extracted it here by applying lookup to that record. So now I can push on the white space beside that structured value to take a peek inside these lists. And these lists contain records. So when I click through them, I see that there are a varying number of records within these lists, right? And I need to extract the final item, so the last item, dynamically from each of these lists, because that will reflect the current phase of each of these projects. Because as a new phase begins, a new record will be added to that list. So to continue my exploration, I can go back to the custom column dialog box by pressing the gear wheel that's on that step name, or I can just modify the code inside the formula bar. Let's do that. So I'm dealing with a list, and that means that I'm probably looking for a list function. So I'll start typing something that starts with an L, and I'm looking for list last, and that is awesome. So it's highlighted in blue. That means that I can use my tab key to select that, insert that into the formula bar, add an opening parentheses there, and of course a closing one at the end, hit that check mark. Awesome. So we dynamically extracted the final list item from each of those lists. And this seems to be the final layer of the structure that we need to navigate, right? There's a null value there, and other than that, I can see the name of the phases that I needed to extract. So there's one more thing to go, and there's one more thing to do, and that's, of course, again, applying lookup, referring to the name, to extract the value that's stored in that field. So directly after the closing parentheses of the list last function, I will again enter a set of square brackets, the lookup operator, and I will enter name. Press that check mark. Oh, that was so close. So I almost got it right, but there's an error in the final row. Let's see what that error message says. I'll click off to the side in the white space. We cannot apply field access to the type null. Now we saw that there was a null value there. So there's probably something that we need to figure out to solve this, right? And the trick is that we need to understand a little bit more about accessing values, because by default, all fields or all items that you access are required. So they need to be present, or an error, something like this, will appear. Now, a simple solution to switch from required to optional access is simply adding a question mark. So here at the end of my expression, I can enter a question mark, and then I will switch from required to optional field access. And when I now hit that tick, right, the error goes away and I get a null value instead. Awesome. This switching from required to optional item access applies to every place where you're applying field or item access, right? So we're applying that here as well. So I can enter question marks if I needed to everywhere where I'm applying item access or field access. So when I hit that tick, nothing changes. Of course, this is a bit of overkill, and I can remove them again. I just want to show you that if a null value is introduced earlier on in the stack of items that you're trying to navigate, you can switch to optional item access at that point. All right. So this is the first part done, right? We've extracted the current phase for each project, and we'll reuse this solution, at least the code for this solution, and apply that to transform nested structures in different manners. So if you have any questions about this process, the process of navigating a structure, now would be a good time to drop that in the chat, because I won't go through this process again. So quick recap, both item and field access are required by default, but you can make them optional by appending a question mark. Navigating a structure is just like providing a set of directions. Take the first left, and when you get to the next crossing, go right, and so on. So the process of applying field and item access, that can be repeated until you've reached your destination. And I find this generates very clean and concise code when compared to using standard library functions. Because yes, there are standard library functions that also allow you to access values in a list, a record, or a table. And we've already seen an example of that because we've used the function list.last to dynamically access the final list item in our list of records. At this time, are there any questions on accessing a value?
There's nothing in the chat, but I'm just going to ask you quickly on this one. I want to paraphrase what the question mark does, and I'd like you to tell me if I'm exactly right on this. But essentially, by putting the question mark at the end, you could have done the same thing, if I'm right, by wrapping the whole list.last phase name in a try to do that. Otherwise, null. Is that correct?
That would just be mitigating the error. So
fair.
You would not switch to optional item access. You would just be mitigating the error.
But effectively, it would return the same result in this case.
In any case, if it resulted in an error, a try and otherwise clause will always allow you to specify a default value to find to offer an alternative if a value cannot be determined. Yeah.
Okay. Cool. Thanks.
Awesome. Right. So let's get back to our scenario then, right? We've developed a solution using the add custom column method. But let's assume that my next action would be to remove the faces column because I no longer needed it, right? Well, in a case like that, you may want to explore an alternative method like replacing a value instead. So since we already have this solution, I'm going to highlight that and I'm going to copy it as well. So I'm going to select it as a whole, press Ctrl+C on my keyboard to copy it. Awesome. I'm going to select the faces column, and on the Transform tab, I'll select Replace Values. I'm not going to do anything in this dialog box. I'm just going to press OK. So performing this action generated the syntax that I needed. Let's take a moment to look at the function that we see inside the formula bar and try to understand what that means and what that does. So the first argument here, and I'll highlight it, that refers to the previous step or the input table on which this function is invoked. And I can revert back to the source by simply replacing that value here and hitting that tick. So the custom column goes away, just like it never happened, and we traveled backwards into time. Now the second argument, that is now an empty text string, but that's the place to put the thing that you are looking for, or the old value, or the matching condition, right? The third argument is for specifying the thing to replace your value by, or the new value. Next, we see a replacer, and it's called replacer replace value. Now, that will replace the entire cell content when the condition is satisfied. So when there's no match, the condition fails and it leaves the value as is. And finally, there's a list with columns to search. And we know it's a list because we recognize those curly brackets, right? So this is a list with column names where the transformation will be applied. Let's fill in the blanks. And we'll start with that second argument. So we need to match the value that's currently on that row. So here it goes. We'll say each and refer to the value that's currently there in the column that we're working on. So I'll use those square brackets again, field access, and refer to phases. And the value to replace it by, that's the solution that we already designed. So I can simply paste that in. So I'll press Ctrl V on my keyboard and I'll hit that tick. Let's see. Awesome. So depending on your scenario, right, replacing values could be an alternative to using a custom column, right? So what did we discover about methods to transform values? Well, the go-to method for most users is using a custom column. And the benefits of a custom column include easy access to all of the fields within the table, right? They can be inserted through that available columns list on the right-hand side. That reduces the risk of typos. Now, other benefit is that it's non-disruptive. The original value will be preserved. However, there may be cases where you can just as easily replace the value. I do realize that the syntax, the syntax that you see inside the formula bar, it looks way more daunting, right? But at the same time, it was really easy for us to incorporate our solution and apply it to that column. I just realized that I used the term non-disruptive, right? And I may need to clarify that, because Power Query cannot perform CRUD type operations, right? It cannot create, update, delete anything at the source, the thing that you're connecting to. Think of it as you're always working on a copy of your data. Just want to be clear on that. Another thing to keep in mind is that with Power Query, you can always go back, right? In the Applied Steps pane, you can select any step in your query, so there is always an audit trail for you to investigate. Awesome. So, any questions on this before we move on?
Yeah, Sergey is asking if there's any difference in significant difference from a performance point of view.
I haven't tested extensively, but I know that this can be less performant. But it depends on what you're doing, what you're using, right? You can do some pretty awesome things with table.replace value. And it depends on how many columns you're trying to transform. You can create a custom replacer, make it a little bit more efficient. But on the whole, I think there may be more performant methods than a table.replace value. But again, it depends on your scenario, and you'll have to do some testing. There's no straight answer, as far as I know. Any other questions?
Nope, that's the only one so far.
It's the only one so far. All right. Well, to be fair, of course, this scenario was very straightforward. We only had a single structure that we needed to transform. But what if you need to transform multiple columns? Does a column-by-column approach, so applying an operation to one column at a time, does that make sense? Surely there must be another method that we can explore. So let's find out next. All right. I've created a different query that looks a bit like the first, but this is slightly more challenged. So here we see a slightly more complex data set, and it contains 5 columns, including the project column that we saw earlier, a members list, and 3 face columns. Now, all of these face columns follow the same structure as the previous example. So the address didn't change, they didn't move. We can reuse the logic that we've already developed for those. So that, when I think about it, that should make this task a breeze. Now, the goal is twofold, right? Extract members from the members list. So let's take a peek inside, and brilliant, just strings. So that shouldn't be hard as well. And of course, then extract all of those face columns, right? Let's get started. And I'll start on the members list because the UI can do pretty awesome stuff. And it can solve this challenge, this mini challenge for us in a breeze, right? I'll hit those sideward arrows, the expand column icon, and there are 2 options there, expand to new rows or extract values. I'm going to select that. And here I can specify a delimiter. Now I like my commas to be followed by a space, so I will select custom and enter a comma and a space. Press OK. Awesome. So the awesome thing is that this completed the task, but better yet, it transformed the members column without adding new columns to my table, right? So let's take a moment to understand the logic inside the formula bar, and I'll expand this a little. There we go. So the action extract values invoked a function that's called table.transform columns. Now the first argument here refers again to the previous step, or the input table, which the function is applied to. That's the source table in this instance. The second argument is a transform operations list, and we can identify it's a list again because we can see those curly brackets. Now, this list has 3 elements inside it, and it follows a specific pattern. So the first item in that list is a text string, and that refers to a column name, the column that will be transformed by this set of operations. The second, that's this part, that is the transform operation, which is a function to be applied to each value within that column. So here we see another each expression, right? We've seen it earlier. Now, each is a function, and that function takes a single argument, the underscore. Now, whatever follows the each expression, that will be applied to each item, in this case, to each item in our column. And the underscore will provide access to the current value as it's processing your data. So here's the each expression, and we can see the underscore that belongs to it right here. All right. And the third, so the final item within our list, that is a type, a value type. Now, this is a part that can be omitted. So because this is an optional part, you may provide transform operations lists that contain 2 or 3 items in it, as long as they follow this structure, a name, an operation, and optionally a type. So this function is actually one of my favorite functions in the M language. And I'm hoping that by the end of this part, you'll maybe feel the same way, because this function can transform multiple columns all at once in a single step by providing additional transform operations list. Now keep in mind though that that second argument that needs to take a single value. So what we need to do is select the entire list, and we need to encapsulate that within another list so we can provide a list with transform operation lists. So I've selected the entire list, and I'll press Shift and an opening curly bracket to encapsulate this list within another list. And I'll press Control C to copy the structure of a transform operations list like this. Now I can add a comma, paste that structure back, and now I can modify the code. So we know what to do, right? Let's transform the phase column. Let's begin with that. So we'll enter phase 1, and we designed logic for that as well. So I'm going to look that up. Here we go. Ooh, need to copy that. Let's step back to our query. Awesome. It generated errors, but that's okay. We're going to fix that. Select the entire transform operation function, paste in our logic, but we need to make a small adjustment here, right? Because this function operates on a column basis and not so much on a row basis. So instead of this phases 1, which by the way isn't a field which is known within this table, I need to replace that with the underscore to access the current item in the column that we are iterating. And the rest of the recipe, the rest of the address remains the same. And of course that will yield a text value as well. So let's see what happens. Awesome. Let's move between my steps. That will make that red line go away. Great. So now we have this transformation list for one of the phase columns. We can quickly create one for the phase 2 and the phase 3 columns as well, right? I'll select that list, press Control C on my keyboard, enter a comma, paste that back, and repeat that process of entering a comma and pasting it back. All I have to do now is adjust the column names. That's all that I have to do. So this will be phase 2, and that will be phase 3. Press that check mark. Awesome. So I don't know about you, but I think this is pretty amazing. You know, we've transformed 4 columns in a single step. But obviously, I have one concern. What if instead of 3 phase columns, I had 30 or 50 phase columns? That could become hard to manage, right? And that's where this function's third parameter comes in, because table.transform columns has an optional third parameter. That allows us to specify a default transformation. So a function that will be applied on all columns that are not listed in any of those transform operations lists. Let's find out how that works. So I'm going to copy the solution again from one of these lists. That's this part. Press Control C. Look for the closing curly bracket of those lists, enter a comma, and there it shows default transformation. I'm going to press Control V to paste that in. And now I can remove all of my phase columns. So look for the end one there, all the way up to, let's see here, press delete. Perfect. I'll hit that check mark. And almost again. There we go. So all of the phase columns, those look awesome. That worked, but the project column now shows an error. And I already explained why that happened, right? A default transformation will be applied to all of the columns within your table that are not listed in any of those transform operations lists. Since we know this, it's easy to fix. We have to add the project column to the transform operations list to exclude it from the default transformation. So I'm going to copy a list here, Paste that back, and now I'll update the content within that list. So instead of the members column, we are going to transform the project column. And here we have that long formula. We don't really need that. We need to bring back the value that's currently there. So all I have to do is replace that logic by an underscore. Need to replace this as well. And that, of course, is a type text. Let's hit that tick mark. Awesome. Perfect. So let's recap, right? Being able to recognize structures in M code is an absolute game changer, right? It speeds up development and can reduce errors by being able to reuse sections of your code. And you've seen me do this a number of times already, right, during this demo. I've been copying and pasting like crazy, reusing building blocks that I found along the way. We also learned that the each expression is a unary function that takes a single argument, the underscore, and whatever follows it will be applied to each item. Now, there are a few things that you'll want to know about the table.transform columns function. It is very flexible, as you've already seen. It allows you to specify transformations for one or multiple columns, all in a single transformation step. Keep in mind, though, that the column may only appear once in those transformation lists. So if a column name appears twice, then an error will be raised. The default transformation will be applied to all columns that are not listed in any of the transform lists. And finally, because this operates on a column basis, you can only have access, or you only have access to the field that's being transformed. So you don't have access to other fields from the same row. That is an important limitation that you need to be aware of. Any questions on this?
Yeah, we got a couple of questions. So
Awesome.
I'm going to roll back here to Henry's got a question. All three phase columns appear to be referring to the last phase. How do we ensure we're getting the first phase, second phase, and third phase instead?
We would have to amend our code if we had to run that scenario. Extracting the first phase, you could use list first, or you could just use the item access operator to extract it by position. There are a number of ways that you can deal with other scenarios if that need arises.
All right, and Jack is asking, the last step of the formula, why is there no comma after the underscore?
The last, let's see.
Yeah, so you've got a list transform underscore comma text.from, and then later on we've got a list last underscore, and we go straight to the phase with a square brace, but there's no comma in between. So it's the one that doesn't have a comma after the underscore, right at the end there.
This one.
That's the one.
That's the one. This is the default transformation. So this is not within a list. This is the default transformation that is a function that will be applied to all of the columns not specified in those transform operations list. So we only have the ability to specify a function here and nothing else. Does that make sense? Does that answer the question?
Good question. I'll let the reader post, Jack, if you want to post back, if that makes sense or not, let us know. And outside of that, the remainder of the things that are happening in the chat right now is just sort of a general comment on performance, but I don't think I want to get you to go into performance at this point because you've got some other stuff going on right now. So let's focus on that. We can always talk about performance near the end if we want to get into that kind of stuff, but yeah, let's not distract your presentation right now. Yeah, so I think that's the end of the questions at the moment.
Perfect. Thank you so much.
No worries.
All right. So, well, we'll round off this section and let's take a look at a different topic altogether, right? It's time to shift our focus to dealing with scope. Now, that is a concept that can be tricky to understand. And especially when you're new to modifying M code, the scope issues tend to come up when you're trying to deal with certain scenarios, like dealing with partial merge keys, ranges, or any type of granularity mismatch. As I promised, I'll walk you through 2 different types of solutions for that scenario as well. But let's start by taking a look at the data. And typically, you'll find a 2-table setup that looks something like this. There is a reporting table, or a reporting structure, I could say. And in this case, it has a code ID, a start date, and an end date. Now, the granularity of this table is a weekly level. So there's 1 row within this table for every week. Then there's an entries table, which is more like a fact table. And that contains daily records in this case. Now, we're not going to modify the entries table because we may also need it further down the line. So the goal is quite simple. We need to aggregate the amount for all of the actuals and report that on a weekly level. That's the thing that we are going to try to achieve. Now, my first demonstration that will be similar to the approach that I see most users take when they're dealing with a scenario that looks something like this. Right, from my perspective, there are 2 main issues that need to be addressed, right? There's only 1 common key between the 2 tables, and that's the code ID. So we have that in the report table as well as in the entries table. But the date here, that needs to be a range, right? Which they don't match up. So the most common approach that I've seen to a scenario like this is starting off with a merge and just using the keys that are present. So from the report table with the code ID selected, I will go to the Home tab and I will use merge. The dialog shows and I can select my entries table. There we go. And now I can map those keys to each other and press OK. Now, this will generate a nested structure with all types and all dates associated to that code ID. So when I click inside here, I have expected and actual numbers, and I have all of the dates, right? So to calculate an actual amount for that period, we need to filter these tables. Now, the good thing is that we can always ask Power Query for help, right, to generate the syntax. That will, again, of course, speed up development and reduce errors. So here's how I would approach that. I'm just going to use one of these tables as a sample. So I'll click on that value to drill down into it. Because I'm looking at a sample, I can now use the user interface to apply the filter logic that I think I need. Now, the first thing I want to do is make sure that the type is equal to actual. So create a filter on that. And I'm going to set a sample date filter, right? So I'll use date. We'll do between, because I need to determine a range of dates. I'm just going to select a random date here and press OK. It's just about generating the syntax for me. Because I've chosen a context-aware filter for the date range, it generated 2 separate filter steps that you can see here in the applied steps pane. Of course, I want to consolidate that into a single filter step. So I'm going to highlight the logic here that we see inside the formula bar. Let's expand that to make sure that I have everything. I'm going to highlight that and I'm going to copy it. Control C. That means that I can remove this step again, refer back to the earlier step. It parenthesized this expression, which isn't really needed. I can use the AND clause because all of my conditions need to be met. and I can paste back that logic that I had copied. Hit that tick, and this filters my table. Now, the only goal that I had was generating this template, if you will, this logical template, right? I can use this to modify all of those nested tables that we saw earlier. So I'm going to highlight the full expression, I'm going to copy that again, and I'm going to remove my steps. Now, this was my drill down step, the entry is 1, so I'll right click that and I'll select delete until end. That will remove the currently selected and all of the steps that follow it. So delete until end, delete. There we go. So we're back to the entries table, the table that we merged and that we need to filter down. So during the first part of this session, I've demonstrated a number of ways to transform nested structures, right? But for simplicity, I'll use a custom column here. And I'll insert that using that mini table icon. That's my favorite place, at least. So there we go. There's our custom column. We can give this a name. So we're going to calculate the actual amount. And now I can paste in the full expression that I generated earlier. And I can use the available fields on the right-hand side to replace the parts of the code to reflect the information here, right? So table.select rows, the first thing here, that is the table that we're going to filter. That is in the entries column. So I've highlighted that section, and all I have to do is double-click entries to insert that in its place. Next we have type, which I don't see here. So that's part of the inner table that is compared against the text string. So that's okay. Then we see date, which I don't see here. Again, that is a part of the inner table. And here I have a date value. Now that needs to be compared to the starting date. So I've highlighted that, and now I can double-click the starting date to insert that. And I can repeat this for the date value here as well. That needs to be smaller than or equal to the end date. So I'm going to double-click that as well and press done. Let's take a look at the results. So I'm going to click off to the side, and there is an error. So the field start date of the record wasn't found. Now, how can that possibly be, right? We can see it on the screen. So what's going on? Now, to understand that, we need to take a closer look at the M code. So I'll expand the formula bar a bit. And the reason that this error occurs is a bit obscured. But we've unintentionally used the same variable to refer to a field from the inner table, the entries table, as well as to fields from the outer table. So that is hidden by the fact that we're allowed to omit the variable that belongs to each expression, the underscore, when we're referring to fields. And we see two each expressions here. Here's an each expression, and here is another one. So when those environments merged, the M engine tried to resolve the conflict that occurred. And it's only looking now at the value closest from its perspective. So for each expression that I've highlighted, it's only considering the columns in the entries table. Now, it tried to look, of course, in that table, and it couldn't find the start date there. And that's why we see this error message on the screen. So to resolve that, we need to make sure that there are unique identifiers. And that requires a bit of additional logic about the each expression, because the each expression is syntax sugar for a function expression that looks like this. It has a parentheses, then it lists the underscore. Let's see, it should be something like this. And then the goes to sign. So this piece of syntax is exactly the same as in each expression. When I click that tick, right, and take another look, the exact same error appears, right? Nothing changed in my code, because these two things can be exchanged, right? This is equal to the each expression. But by using an each expression, we can now rename the variable that is being used, ensuring that we get a unique identifier. And that means by renaming that variable, right, that we're also no longer allowed to omit it. We're only allowed to omit the underscore. So if we give this another name, let's call that E for entries, right? Then I have to prefix all of the fields from the inner table with the E as well. So this type column, that is from the entries table. So I'll have to prefix an E there. Date comes from the inner entries table as well. So I have to prefix that. Start date is coming from the outer table. So that has that imaginary underscore in front of it that we're allowed to omit. And date again is coming from the inner table as well. So when I now hit that check mark and look off, or when I press on the white space, the error has been resolved. Now this actually was the difficult part, right? The final steps are very easy because we can look at the values in the amount column and simply sum them up. Now we've got the correct range. Let's do that. Use the lookup operator. So that's a set of those square brackets that we've seen earlier as well. Refer to amount. Hit that check mark. And we now get a list with those column values. Awesome. And we can sum those values up. Let's lose list sum. Let's see. Let's try that. There we go. Hit that check mark. Awesome. All right. Perfect. So admittedly, we had a bit of a challenge on our hands, right? But we were able to resolve it. The thing is that it's very difficult, I think, for people who are new to the M language to understand the problem that arose without any context as to why that happened. But at the beginning, I also promised that I would show an alternative, right? A second method. I think it's way more simple than this. Plus, the added bonus, at least, the added bonus for me is I get to showcase another of my favorite functions. So here we go. I've prepared an actuals table, so I'll select that. And this table references the entries table, so the table that we're not going to adjust or mutate in any kind of way. I've referenced that, so I didn't copy any of the code. It's just taking the output of that query as a starting point. And then I've placed a filter on the type equals actual. So that's the table that we're looking at right now. Now, of course, the goal remains the same. We have to create a reporting table that has an actual amount on a weekly level, showing a start and an end date for each week. So to do that, I will highlight the date column here, and I will transform this value. So I'll go to transform, select date, go to week, select start of week. And this calls the function that we saw earlier, a table.transform columns. Now, the thing that I want to do is make sure that this column not returns 1, but it returns 2 values, right? And because it is more than 1, I have to create a structure to hold that value. So let's take a look at how that works. I'll open up the formula bar a bit, and instead of this expression, which I'll modify a bit because I want my weeks to start on a Monday. I can say each, because we're working through each of the values of this column. Add a set of parentheses, and now I can pass in the underscore for the current value that we're iterating as we're working through our column, and set the starting day to a Monday. There we go. So this gets us one date, but as I said, I want to return 2 dates. I want to create the end date as well. To store that value, I will use a record, but to be fair, if you prefer a list or a table, that's fine as well. It just has to be a structure because it's more than one thing. That's the only thing that you have to remember. So I'll initialize a record. I'll highlight my function here. I'll use my square brackets to create a record. So wrap that around the outside, and I'll copy this logic. Let's give this field a name. So this will be the start date. And that's equal to this expression. Now, of course, I can insert a comma to add another field to this record. I'll paste in the same logic, and we'll give this a name as well. This will become the end date, equal to this expression. Of course, we need to update it. That won't be the start of the week, but that will be the end of the week. So end. There we go. And of course, the return value type, that needs to become a record expression as well. I'll highlight my full record, copy that, paste it in here, and my start date, that is equal to a date. And so is my end date. That is equal to a date as well. I'll hit that check. And now we see that we've created a record. Let's expand the fields there, a start date and an end date. Awesome. So one more thing to do, and that's quite easy. Summing up the values in the amount columns. Now, all I have to do is select all of my keys. So that's the start date, the end date, and the code ID. And now I can use my other favorite function, and that is group by. I'll select that. Because I selected multiple columns, it added them here to the grouping. So they're used as grouping keys. And now I can set an operation. We want to sum values in our amount column, and we'll call that the actual amount. Let's press OK. Now, the only thing is that the code ID is here, but we can quickly swap that around. I'll exit out here, and I'll place it to the front of the line. There we go. Hit that check mark again. Awesome. And it also amended the order. Perfect. So I think this solution, this approach, is way more easy to manage, right? But, let me know your thoughts. Also, the group by function or table.group is very versatile, and it's one of my favorite functions. There's tremendous power for solving more complex challenges, but that's maybe that's a story for another time. So what are the key takeaways, right? Well, I think the most important part is that you can use drill down and leverage the strengths of the Power Query editor to quickly generate code that can be applied to nested structures, in this case, nested tables. And that can have a massive impact on the number of scenarios that you're able to solve. When you require fields from an outer or parent table to filter nested tables, make sure that your identifiers are unique by using a function expression to refer to the fields within either the outer or the inner table. So during this session, we covered several methods to transform values. We've used the custom column, replace values, and transform columns. I can only hope, of course, that some of these gold nuggets that we have unearthed today are useful to you in practice, and of course that you'll have fun exploring N. So before we wrap up, are there any questions?
I've got a couple here. Can you expand the formula bar right now so that we can see the final code for that particular step?
Sure.
Perfect. Awesome. That was easy. So the other one is around the file. Will the file be available? Because our good friend Christian Engel wants to try and see whether or not these solutions will fold against a database if they're applied there or not. So he's hoping to just import and borrow your code. So awesome. So I don't know if there's other questions. If anybody does have any questions, please throw them into the chat. Melissa, I just want to tell you something. Obviously, I've worked with Power Query for a long time, and I think this is the first time that I've ever actually watched somebody live replace the each statement with the function definition, change the name of the argument, and then preface the different components inside there to be able to refer to the inner table versus the outer table effectively. That is game changing. That is awesome. I'm so glad that you showed that. Very, very cool stuff, and is probably my biggest takeaway from today. So really appreciate it. Really cool. Yeah, just some the things that I see coming in here. Just your fan club is posting messages right now about how much they love you. So that's what we got going on in the chat right now. Anyway, thank you very much for coming to do this. I really appreciate having you here. Great presentation. Thanks everyone for coming and being part of this as well. If you got any questions, fire them into the chat real quick before Melissa runs away for today. I do want to just sort of also remind everybody. Well, say another thanks to Joseph for doing the What's New in Power BI for today as well. And again, Melissa, thank you so much for coming and doing this great presentation. Really enjoyed it, and looking forward to having you back at some point in the future. Congratulations, by the way, on the big change that happened between last time you were here and now with your MVP award as well. Very much well deserved, and glad to see you part of that club at last. So,
thank you so much.
No worries. And yeah, I don't see any other questions coming in. So. Do you have any links or resources that you want to share before we wind up for today?
I think everything was on the slide already, and is also in the Meetup link. Just if anybody wants to reach out, please do that via LinkedIn. You'll have the biggest chance of catching me.
Excellent. Awesome. All right. Well, thank you very much for coming today. We'll wrap up for today, folks. I'm going to get the meeting produced and published within the next 24 to 48 hours. Once it is live, we will go and actually post on the Meetup group, so you get notified of it. And don't forget that the RSVPs for the next meetups are open. We hope to see you at one of them. Till next time, folks. Thanks very much. See you again.